Okay, so continuing our discussion, no? So let us move on to our next example. Okay, so probably these examples um generalize those previous examples na solve natin. Okay, so it uh, actually concluded those idea na meron tayong heat transfer, at the same time uh, meron din tayong energies and then internal energy in this example, no? So just refer on your manual. So sabi dito, air is contained in a vertical piston cylinder assembly fitted with an electrical resistor. Okay, so fitted with an electrical resistor. So the atmosphere exerts a pressure of 14.7 pound force per inch squared on the top of the piston, which has a mass of 100 pounds and face area of 1 feet squared. Okay, so ibig sabihin the atmosphere exerting a force here dito sa surface ng piston natin. So electric current passes through the resistor. Okay, so may resistor tayo, and the volume of the air slowly increased by 1.6 feet cube, okay, while its pressure remains constant. Okay, so the mass of the air is 0.6 pounds and its specific internal energy increases by 18 British thermal unit per pounds, and the air and the piston are at rest initially and finally. Okay, so ibig sabihin our change of volume is a property, no? So ibig sabihin it is actually a quasi equilibrium process, no? So the mass of the so the piston cylinder material is a ceramic composite and thus a good insulator. Okay, so friction between the piston cylinder wall can be ignored, and the local acceleration of gravity is g is equals to 32.0 feet per second squared. So determine mo daw yung heat transfer from the resistor to the air in BTU for system consisting of, for A, the air alone, and for B, the air and the piston. Okay, so in this case, since sabi niya dito, it is the wall of this piston is insulator, no, purely insulator. So ibig sabihin the traveling of heat from this air papunta sa labas sa surroundings is not applicable, no? So it means that ang kukunin lang natin dito actually na heat is the heat transferred from the resistor na nakikita natin dito to the air na nasa loob ng piston. Okay, considering the air as a system in letter A, and then the air and the piston as a whole as a system in letter B. Okay, so yun yung question dito, no? So again, ang hahanapin natin dito is to find the heat transfer from the resistor papunta kay air. Okay, so meron tayong engineering model dito, no? The first model is two closed system are under consideration as shown in the schematic, no? So the first system is the air itself. Okay, air lang, so hindi kasali yung whole system. So the second system is air including the piston, no? So lahat. Okay, so number 2, the only significant heat transfer is from the resistor to air, during which the air expands slowly and the pressure remains constant. So ito yung sinasabi ko, no? So the only heat transfer is from the resistor papunta kay air. So hindi kasali yung sa surroundings, no? Kasi sabi nga itong wall ng piston na to is an insulator, okay? Purely insulator. So hindi diyan pwede mag-travel yung heat natin. So pangatlo is there is no net change in kinetic energy. Then the change of potential energy of the air is negligible, and since the piston material is good insulator, the internal energy of the piston is not affected by the heat transfer, no? So, the change of kinetic energy and the change of potential energy is zero. So, yun lang yung ibig sabihin ng pangatlo na yan, okay? And the internal energy is not affected. So, ibig sabihin may value yung change of internal energy natin, okay? For number 4 naman, we have the friction between the piston and cylinder wall is negligible, no? So, ibig sabihin the pressure is constant, no? ibig sabihin throughout this movement of this piston here, the pressure that is experienced by the system or air is constant. So number 5 is the acceleration of gravity is constant, which is equals to 32.0 feet per second squared. Okay, so yun. Now, dito tayo sa analysis. So for letter A, no, by assuming that the only system is the air, so taking the air as the system only, no, not including the piston. Okay, the energy balance of equation 2.35 reduces with the assumption 3, no. So ito yung energy balance natin. Equation of energy balance, we have meron tayong change of kinetic energy plus change of potential energy plus change of internal energy of air is equals to heat transfer minus the work that is being done, no. So sabi dito, since 0 yung 0 naman, no, assumption natin sa number 3, since 0 naman yung change of kinetic energy natin, at the same time yung change of potential energy natin, so we have just to cancel out that one. Okay, so yun yung mangyayari. Okay, now solving for Q here, so or heat, we have W transpose natin yung negative work. So all in all, we have heat is equals to work plus change of internal energy of air. Okay, so for this system, work is done by the force of the pressure P acting on the bottom of the piston as the air expands, with equation 2.17 the assumption of constant pressure, no. So since we have already assumed here that the pressure is constant by the assumption for number 4, no, sabi dito friction between the piston and cylinder wall is negligible. Since we have already assumed that the pressure is constant, yun yung ibig sabihin ng assumption number 4 na yan. So hindi na natin kailangang kumuha ng expression for P in terms of V para maka-integrate tayo rito, no, unlike sa previous natin kanina na example na kailangan pa natin kunin yung relationship nila. So for example, yung P Vn is equals to constant, no. This is for polyotropic process, no. This is for polyotropic process, no. So hindi na natin to siya kakailanganin just because we already assume here that the friction between the piston and cylinder wall is negligible. It means that the pressure is constant. Okay, so in this case, since pressure is constant, we can already have integrate this dV here. Since constant naman yung P natin, so we can just say that P multiplied by V2 minus V1. Okay, so yun yung ibig sabihin nun. Okay, so since ang problema lang natin dito, meron naman tayong given na V2 at saka V1. Ang problema lang natin dito to find the work is the pressure, no? So now to determine the pressure P, we use a force balance on the slowly moving frictionless piston. Then the upward force exerted by the air on the bottom of the piston equals the weight of the piston plus the downward force of the atmosphere acting on the top of the piston in symbols. Okay, so ibig sabihin lang nun, gagamitin mo yung mechanics dito, no, yung summation of forces along vertical, no. So we have, kasi since itong part na to, we have P multiplied by area of the piston, that is actually the pressure or force that is being exerted by the air sa piston na to. Okay, so equals to mass of the piston. Okay, mass of the piston, ito yung mass nito, plus the gravitational acceleration plus multiplied by gravitational acceleration kasi force man siya, weight, no, weight, then plus PATM yung pressure ng atmosphere multiplied by the area of the piston, no. So bakit ganito yung natin? Kasi because bakit ganito yung equation natin? Because yung itong P multiplied by area of the piston is direction niya is pataas yun siya actually, no, pataas. Tapos yung weight ng piston is pababa, syempre, no, pababa yan siya. At the same time, yung pressure or yung force na na-exert ng atmosphere dito kay piston is pababa rin, no. So that's why yung itong force na to is pataas, tapos it is equals to the downward forces. Okay, so yan. So in this case, para makuha mo yung pressure, just use this one kasi alam mo naman actually yung PETM, no, pressure ng ATM, alam mo rin yung area ng piston, alam mo rin yung mass ng piston, then alam mo rin yung value ng G. So alam mo rin yung area ng piston dito, so you can already have the value for P, okay? So, or pressure, no? So, by calculating the pressure, here, no, solving the equation of that, so we have M piston G over area of the piston plus P ATM, no? So by substituting all the value and then converting it to the units na comfortable sa atin, in which it is lbf per inch squared, no? Kasi in this case, kung isa-substitute natin yung value natin, okay, anyway, kung isa-substitute natin yung value pala natin, magiging inch squared yan siya, no? Kasi meron tayong conversion from feet squared to inch squared. Okay, so yun talaga yung aim natin, no? So we have the resulting one is 15.4 pound force divided by pound force per inch squared. Okay, so yun yung result, no? So okay, so the work, therefore, no, we can already have the value for work, no? So the work done is, again, nakuha na natin yung pressure, so substitute the value, just substitute the value. We have 15.4 lbf per inch squared, tapos multiplied by the okay, convert natin yung inch squared sa feet, no? So we have 1.6 feet. Okay, no, this is the change of volume pala, no? 1.6 feet cube. Tapos convert natin yung inch, okay, yung inch sa feet para uniform tayo, no? Diretso tayo sa BTU kasi we know that 1 BTU is equals to 778 feet lbf, no, or pound force. So we can just cancel out that one. Okay, so the resulting one is 4.56 BTU, no? Then after we find the value for work, we can now find the value for heat transfer, no, by using the equation that we have already derived kanina, no? We have 4.56 BTU plus yung mass ng air, kasi ang given man is given na internal energy natin is specific, so that's why kakailanganin pa natin siyang i-multiply ng mass, no? So mass ng air, which is equals to 0.6 pounds multiplied by 18 BTU per pounds. Ito yung specific internal energy ng air natin, no? So multiplying that one, cancel out yung LB, so the remaining or the result would be 15.36 BTU. So ito na mismo yung heat transfer natin, 15.36 BTU or British thermal units.